My name's Steve Mustard. I live in Houston, Texas. I'm originally from the UK. I'm an instrumentation and control engineer by background. I've worked in multiple critical infrastructure sectors for 35 plus years. And 20 or so of those years I've worked in cybersecurity in those critical infrastructure environments. So what I'm going to talk to you about is some of the work I've done in that area that uses technology to make cybersecurity incident response more effective. So Don did a great introduction to the importance of cybersecurity incident response. He talked about it being one of SAN's top 5 controls. He also mentioned that comment in the 410 class where it talks about response being critical. So when I talk to customers, the one thing I start by saying is that you've got to have an incident response plan in place. You can do all of the cybersecurity controls that are in all of the guides and standards and regulations that are out there, but if you don't have an incident response plan, you're not going to be able to respond when you need to. And the second thing I tell people is once you've got an incident response plan, you have to test it. And those are the two worst things I see. You may see things differently, but in cybersecurity, the two worst things are no one has a plan, and then even if they do have a plan, it's filed away somewhere and no one ever looks at it. And so the only time they ever look at it is when they have an incident, and then they find out the plan doesn't work. So given that it's important to have a plan, and it's important to test a plan, how do you go about doing that? So traditionally, most people use tabletop exercises. So you get a room, a bit like I've got here, you get a bunch of experts from all different disciplines, you all sit together, and then you talk through an incident. So you can do this in safety, and you can do this in cybersecurity. You say, there's this incident that's happened, what do we do? And everybody talks about what they're going to do, and you kind of go through the routine sitting around the table. And that works okay, that's pretty good. You can learn a lot from that. You can certainly make sure that the plan should work and people know what they're supposed to do and the contact numbers are correct and all the procedures are there and the backups are in the right place and all that sort of stuff. What that doesn't do is, I would say the main thing is it doesn't create a sense of realism. So sitting around a table, pretending there's an incident is not the same as being in the middle of an incident. So that's the first thing. The second thing is that when you do those tabletop exercises, they tend to be fairly well scripted. You may not be working with any kind of software at all. You might be literally just working from a script and just working through this. And all the injects and all of the scenarios are predetermined, and there's no flexibility. So it becomes a bit of a routine for people. And it's not really very effective again as a result. You know, you want to make these things as realistic as possible. And to be as realistic as possible, things happen that you're not expecting to happen. So what do you do? So if you want to do something more realistic, what can you do? So one of the things you could do is you can actually do a real exercise in a real facility. So everybody's been through a fire drill, I'm sure, in a hotel or an office. And you all hear the alarm go off, and then you have to stand up and you have to go to the muster point, and maybe people check your names and whatever the procedure is, and you do that periodically, and that helps people to orient themselves about where they need to go if there is a real fire, and kind of at least it happens in real time and it happens in the environment that you're supposed to be. So it's pretty good. But what do you do if your facility is 130 miles off the coast of Louisiana and the only way to get there is by helicopter, and the helicopter flight alone costs about $20,000, and you're in an operational facility. So this facility is producing oil and gas. It's got high pressures, high temperatures. The control system that's on there is there to keep everybody safe and secure. And you want to do an exercise which involves potentially impacting that system, it's not something that's easy to do. But I actually did that. So a couple of years ago, I did an exercise at this facility that you can see here in the middle. And only one person on the facility knew why I was there to do this exercise. Everybody else thought I was there to do an audit, the kind of thing that Don was talking about. And so they knew I was there, they knew what I did, but they didn't know that I was going to do this. So on a particular day, I got the vendor to trigger this simulated ransomware incident on one of the consoles in the control room. So this particular console is called the Marine Operator Console. It's also called the Ballast Control System. So that's the system that they monitor to make sure this platform, which is floating, so this is chained to the seabed. It's about a mile deep, and this just floats. And there's a control system that controls the chains, and there's a control system that controls the ballast tanks, and they adjust all of those things in real time to keep it stable. And the person who's monitoring this is monitoring that because if they're not careful, it could capsize. So we simulated this ransomware. It's not real ransomware. It's literally just a JPEG image that popped up on the screen, and it didn't actually interfere with the control system operation at all, but the operator didn't know that. So before I did this, I'd already developed the incident response plan with the operations team, so that if we had an incident like this, there was a procedure that they would follow to respond to it. And I won't go into details about the response itself, but the good news is that once they saw this ransomware, aside from asking each other how much 300 bitcoins was and whether they were able to, what they were going to do about that, they did the right thing. They called the OIM, the Offshore Installation Manager, in, and you can see the picture at the top left there. That's the guy in the baseball hat. He's looking at the screen. He knows why it's there, but he's not going to tell them that. So they're telling him what's happened, and they're going through it, and they get the plan out, and they actually go through step by step. So you can see the picture below that is the marine operator who's got the plan in his hand, and he's reading through step by step what they've got to do. One of the parts of the step is they've got to go in the equipment room, which is the picture on the top right, and they've got to disconnect the facility from the external network. That's part of the procedure to isolate it, that kind of islanding thing that we talked about earlier, to stop the spread of ransomware potentially to the rest of the network, but also to stop any further ingress from any other unauthorized users. And then the other part of this is to go into this other room, which you can see at the bottom right, which is called the Incident Command Center. So if there's any kind of incident at all, be it a loss of containment or cybersecurity incident like this, everyone convenes in that room, and I mean everyone in terms of the leadership. So it's the safety leadership and the operations leadership and the maintenance, and all of those people congregate in that room, and they talk about what to do. They record things on the board with the times and everything, and it's all very strict and organized. So they made it a very realistic exercise. Obviously, eventually, the operators realized it was an exercise. But one of the things that they said is that even once they realized it was an exercise, they still felt the pressure to respond correctly and do the right things because they knew that it felt real, and so they felt like, I have to do the right thing. So that was really good. But you're not going to do that every time. It's hard to get approval to do something like that. It took a lot of approval in that organization to get me to be able to do that because of all the risks involved in doing it. And it's very expensive to do, and so you're not going to do it very often. And of course, one of the things we know to do with incident response is to do it as often as possible. So what can you do? So technology is here to help us. So what I thought is what we need to do is find a way to make something more realistic than a tabletop exercise, but didn't require actually going to a facility, could be done anywhere, could be done multiple times, and could be used to actually not just prepare people, but also train people to be better at incident response. So there's two key parts to this. One is, how do you generate the scenario so you don't have a scripted scenario that's the same each time and it's got no flexibility? And then the second thing is, how do you make it look realistic? So the first thing you can solve with AI, generative AI in that case. So you can create a large language model. You can fill that large language model with things like real cybersecurity incident data. You can fill it with frameworks, attack frameworks, and controls, and standards and guidelines, information and recommendations, and vulnerabilities, and so on and so on and so on. So you can kind of basically dump a whole load of information in there and let the large language model associate all of these words that are in all of this information and make something out of it for you. And then you can use that to do things like generate a scenario and ask someone to respond to that scenario, and then your response to that scenario can generate further scenarios. So it can be interactive. And then on top of that, you want to make it realistic, so the obvious thing to do is to use virtual reality and some kind of immersive type of technology. So if you can create a 3D representation of the organ facility that you're going to do the simulation in, then you can use various types of immersive technology to view that. So the picture here, someone's wearing a Meta Quest headset, and you can see what he can see on the screen, on the big screen, but he's basically immersed in a 3D representation of that control room you saw earlier. It's actually literally the 3D model of the literal control room that I did the exercise in. So we rendered that in 3D and put that into the environment, and then connected that up with this large language model to generate the scenario. So what you can see here is some other ways you can visualize this. So I don't know how many people have used virtual reality headsets, but they can be very disorienting. So some people find them difficult to use. Some people find them too strenuous to use for long periods of time. And so it's useful to look at other options that you can use to visualize things. So another option you've got is an immersive room. So this is an immersive room from a company called Igloo Vision. And they make basically, they convert a room. They either convert an existing room, or you can build a room of different shapes and sizes. So you can build a cylinder, you can build a literal igloo, you can build a cube, and you can fill an existing room with cameras so that they project the 3D environment onto all the surfaces of the room, so including the floor and the ceiling. So one of the nice things about that environment is that you can have lots of people in the room at the same time doing the exercise, but you can actually see each other, and you can see the actual person, and you can interact with the actual person and talk to the actual person. When you're wearing the Quest headset, you can do the same thing. You can interact with other people in the metaverse, but if you've ever tried any of those, you'll know that there's some limitations, like people don't have legs, for instance, so you're kind of looking at an avatar of someone who has no legs and they're floating around, and it's less realistic. It's still effective, it's still better than a tabletop exercise, but it's not as realistic as being in an environment like this. So these rooms can be useful. Obviously, the disadvantage of this is it's a physical room, so it has to be in a particular place. The Quest headset, you can be anywhere in the world, and in fact, individual users could be anywhere in the world and interact with each other in the same environment at the same time. So it's really powerful from that point of view, but it kind of depends on what your requirement is as to what you do. So we're trying to not make something where it's specifically to a particular type of technology, but try and use the basic technology of immersive environments in different ways. As you can see in these pictures as well, on the right-hand side, you can see the same environment that you saw in the previous picture, which is that control room environment. On the left-hand side, you can see a different environment. So all we changed in this case is the 3D representation. So in this case, we've made a manufacturing facility with robot arms and a production line making, in this case, 3D printers. And we can change the scenario that the AI generates to be specific to a manufacturing line rather than an offshore production platform, just by making some changes to the prompts that we give to the AI. So again, we've got this large language model. It's not specific to one scenario. It's got lots of information about different critical infrastructures. It's got lots of information about different types of incidents, different types of systems, different types of technology. So you can easily program it with prompts to create a different type of scenario that matches the 3D environment very easily. And producing 3D environments pretty easy, you know, in terms of you can build a model like that. That one, the first one is built using the construction model for the actual platform. The other one is built using fairly low-cost 3D models of things that you can buy off the internet, and you just put them all together. Obviously, I say just, it's not that easy, but it's not difficult to do, and it's very powerful when you do it. So got a little video here, which I'm going to play, and it'll give you a bit more of a feel. It's still not as immersive as it would be if you put the glasses on, of course, because you're looking at it on a 2D plane, and you don't really see the immersiveness of it. I can tell you, if you put the glasses on and you walk around this room and you walk too fast, you'll get very nauseous quickly. But anyway, what you can see at the front of this is this AI interface. So that's the prompt engine, if you like, that we use to interact with the AI. And you can see there it says start new exercise. So you would start a new exercise, and then it's going to tell you what the scenario is. It's going to ask you what you do first. And then you can either type using the keyboard that's on the 3D glasses, or you can type using the keyboard that's in the 3D environment, or you can speak to it, and it'll convert your speech to text, and then it will allow you to enter the text that way. So you'll see this is an example with the Quest headset, so you can see on the computer screen what the person can see as they're moving around. And what you can see here is a lot of flashing lights. And I added the flashing lights, and you can't hear the audible sounds, but if there was a safety incident on that platform, you'd see lights, but you'd also have audible alerts on the public address system telling you that there was an issue. And that kind of flashing lights and the noise is there to create that sense of realism, but also that additional stress on the operators when they're doing this exercise. So you want them to be stressed to try and respond correctly, but you also want them to feel the extra stress of knowing that there's all this stuff happening behind them. So in this particular scenario, we set it up so that there was about a 10-minute window, and the platform, because basically the control system has been corrupted, the ballast tanks are being emptied on one side and filled on the other side, so it gradually capsizes. And then once it gets beyond about 3 degrees of tilt, it will just capsize. And so the idea is that you can see a little model in the screen, and it's gradually capsizing. And as you're trying to respond and trying to do the right things to stop the spread of ransomware, you can kind of see this thing happening in real time. So, so one of the things that you probably can't see from, let me just play at the end. Not only can you do this exercise and get this sense of realism and respond in real time and have the thing respond to you with, whether that made it better or worse. At the end of the exercise, you might see that it will actually give you a report. So it actually gives you a report which gives you some objective data about how you perform. So it will give you a score between 0 and 100. It will also give you some metrics on how much the remediation would cost as a result of what you did, how promptly you responded, and in terms of how much downtime potentially that you had if it was a manufacturing facility, and also things like the kind of responses you did, the kind of controls or the kind of actions that you took, and whether or not they were effective. So there's no one answer, as you know, with a cybersecurity incident response. There's no perfect answer. So you can't really just say there's a score out of 0 to 100. What you want to be able to say is, yeah, you did well overall. You could do better here. You could have used some different responses. You could have done things in a different order. And there you can see the report there. Gives you a summary. It actually refers to things like the MITRE attack framework in terms of the injects that we used. And so you can get a good feel for what you did well and what you didn't do well. So what you can do with that, in fact, what the developers I had who developed the VR part of that had no knowledge of cybersecurity at all when they started this. So if you imagine they're testing this all the time, and they're running through these scenarios, the same scenario over and over again. One of the guys started, he got like 40% when he first started because he knew nothing about cybersecurity. And he kept repeating the same exercise, and after a few weeks, he was like 85%. So he actually, without any knowledge of cybersecurity, just using this, he learned himself how to better respond to a cybersecurity incident because the AI was giving him feedback on how well he did, what he could have done better, and he was using that knowledge to improve how he did it. So this is why I think technology can really help. I know there's a lot of presentations that are going to happen over the next few days about AI and the risks of using AI, and that makes people nervous about AI, and it makes them think that they can't use it at all. I think that AI can be used to actually really complement what people do and make things better. It has to be used in the right way, it has to be used carefully, and it has to be used under strict supervision with humans in the loop. But if you can use technology like this, you can greatly save a lot of time and money and improve things and make things better for everyone. So that's all I wanted to tell you about, apart from if you want to see this VR simulator, where there's booth D8, which is at the other end by the IoT auditorium, you can actually try it out. So you can have a go yourself and get seasick and see what you think of it. That's my contact details, and there's some of my books that I've written about cybersecurity. And thank you. So I left time for questions, hopefully. So if you have any, and if you don't, that's fine.
Thank you, Steve. If anybody has a question, if you just raise your hand, I can bring a microphone over to you. I think we got about 5-7 minutes. Anyone? Okay. I don't see any hands, so that's going to conclude our morning sessions. Again, as Steve said, if you want to talk to him or maybe you have a question after you start thinking about a few things, I've been to his booth. It's all the way down at the end of the hallway, right near the entrance. So we are going to start back up in here at 1500 for our afternoon session. So right now is a break. Time to go grab some lunch and something to drink, and I appreciate it, and see you this afternoon. Thank you.